Thank you for today. This is Newfound Gold, the land of golden opportunity, a prospector's perspective. So today's talk, I'm going to talk a little bit about the gold exploration history on the island. And then I'm going to talk a little bit about the Newfoundland Geological Survey. They help the science, they help set the stage for the science stage, as I call it. It all starts with a good gold map. And the idea is that this is a unique geological setting, it's a structural story, and it's the perfect gold timing event. The other topic we're going to talk about is the geological potential, from Cape Ray to Bay Burt and everything in between. It's a structural story. And then I'll finish off with geochemistry, what works, what didn't, show some case studies, and how we're about to approach this on the island. So Newfoundland's got a rich mining history. They've been basically mining since the 1800s for copper. And, they've got really cheap electrical prices on the island. They have roads almost everywhere. And there's a water port anywhere within the island within 125 kilometers. So infrastructure is very good. But the best thing for the island was it's Newfoundlanders. They're basically the best resources for miners across Canada. They go to Alberta, Ontario, Quebec. So they're true miners, and they've been doing this for a while. So it'd be great to find them a mine to work in Newfoundland, so they don't have to travel all over the country. The next thing I'm going to talk about is basically the history of the exploration. And this slide is showing you some stats. Here's the gold price in the background. This is gold, $400 an ounce right here. And the idea is that they came in waves, and this is the 1988 to 89 exploration boom. And this is what I'm getting at, that we haven't seen a big boom like this for a while. And so this was based on the lake sediment sampling that they released, and but it was short-lived because of the 89, the super flow-through crash in Canada, and pretty well everybody was out of a job here working in the bush. But you could see that here's our 91 to 96 cycle, not too many claims, very little work was done. And it started to peak up a little bit in 96, but then the 97 Bre-X crash hit. And this is 97 to 2001. And this is when they started changing the staking law, roughly around year 2000. So you can see more claims are added on. And really what it is the prospectors are picking up some ground. The next little boom rush was 2002 to 2004. And this was mostly Rubicon, Crosshairs, and Cornerstone work in the area. And really what I'm showing you here is the area that was in the Gander area north and the cycle. So it's kind of the micro to the macro. But the idea is that you can see now more claims are staked. Some money was spent in airborne stuff like that. But that was short-lived. Gold never actually cracked $400 at that point. And by 2005, everybody went home. And so they didn't actually get hit with a big cycle, even when the gold boomed up by 2011. So this is what I'm getting at. The exploration is basically was all from the 88 to 89 rush. And here's another graph looking at it, basically claims in red versus dollars spent per claim. And you could see a lot of money was spent per claim. They didn't have a ton of claims. That was Noranda mostly. And the idea was, when you look at this cycle, 80% of the gold discoveries on the island was from this 88 to 89 cycle. And then you can see what happens here as basically the, just pre-Bre-X. This is the Bre-X. And this is when they went to paper staking, and you could see lots of claims were picked up. And really what this is the prospectors were picking up some of the old showings from the 89 to 90 rush. And then you get the 2002 to 4. This was Cornerstone coming in with Rubicon. They flew some airbornes. They looked at the big package, staked a lot of ground. But again, gold never broke $400. But they actually did find around 15% of the rest of the gold showings that were discovered that we know about right now on the island. And again, the cycle continues. When everybody left, some claims were picked up, and the ebbs and webs. And the whole idea is that basically 5%, or roughly, and this was roughly that I'm breaking apart, of the newest gold discoveries were discovered in this kind of 2010 to 12 era. But again, you could see not too much money being spent. So that's kind of the micro to the macro of the whole island, in a sense, is The biggest push was the 88 to 89 rush, and there's a reason for that, and I'll get to that soon. So, but this is the real reason why I survey. These guys produced some of the best data that I've ever seen to work with. And the unique thing is, it was their staff. They basically had geologists working the ground for 30 years, the same guys. There's one guy that's been there for 40 years. You know, he just loves working. And the idea was the consistency of their geology maps that they put out. They actually have a geophysicist on staff that basically helps to produce some of these nice geophysical maps. And he's been there for 25 years. You know, they actually had a crew, a surficial geologist working for another 25 years. So these guys were there, and, you know, they were building this database since this 88, 89 rush. And that's kind of what I'm getting at. We actually have now 30 years worth of data to work with. And they even have surficial geologists working with them. So that's what's kind of really cool, is the data they produced was like, it was exceptional here. So now, geologically, what's so special about the island? Really, this is geology on a continental scale that was developing. Here we have Newfoundland down here. And you can see how here's West Africa, and basically, you know, here's the Baltics. And really what this was all about was a collision event of these continents crossing the Atlantic and hitting the North American continent. And here you can see it here. You have different slivers of continent that cut across the ocean and all basically started colliding with the, basically, with the mainland. And now when you look at it from this scale, these are these big regional structures. And this is the Bay Bird line. And you can see it comes all the way up through basically Ireland and up through England. There's the Red Indian line, main structural event coming all the way down, even down to the North Carolinas. The Dog Bay line, the Grub Bay line. So these are big fundamental structures, you know, that help set up this whole event. Now, this is a good little cartoon to explain. And here's a time schedule, like 450 million years old to 435. Basically, this continent called Gandaria collides in with Laurentia, and it starts to create this structural pattern here. And this inset up here is actually what we're looking at. But here, this is what's kind of going on, 435 to 429. Now we get these slab breakoffs, and this creates, basically it's dumping big chunks of the continent, or this piece of rock continent, into the mantle. It basically volatiles and comes up and forms these gabbros and intrusives, but it basically creates these extra fluids that come up. And then 429 to 420, this is when the kind of really cool, it actually reverses a bit. And the analogy is kind of like when a schooner hits a shoal, because we're on an island, we'll talk boats, and when it collides and hits a shoal, it cracks the floorboard, and as soon as you pull away from that shoal, the water starts to pour in up through the floorboard, through the cracks. And this is what the setting here, when the continent collided, it created these faults. And when it kind of rebounded a little bit, it's called eduction, the fluids came up through the cracks because they relaxed. And that's what's kind of unique about this setting. Now, will the timing of the gold mineralization, it's actually perfectly in sync. So another good, and that's what I'm showing you. I'm actually working pretty well all with the, you know, the Newfoundland Geological Survey data. This is a report from Hamish. He's giving a talk here. And the idea is that this is, he's studying the ages of the mineralized event and the ages of rocks and giving us these nice structural maps to actually try to understand it. And here he's got, this is just one of his maps, but it's showing you this 419 event, mineralized event. So now when we put this into context with that cartoon that I showed you earlier, and this is kind of a bunch of his gold, basically sampling or age dates that he have. And so here you see the 450 to 435, just as the continent collides. This is the beginning of the selenic event, and then 435 to 429. You could start to see, this is basically when, like, you could start to see all these cracks, these basically the breakoff slab. But this is the actual gold pulse. We're looking at the gold pulse event here. And as this thing, the eduction event happens, when it starts to rebound, here's the 429 to 420. This is the 420, 419 mark. You can see this is right in the peak of actually the gold pulse event. So the fluids coming up through the floorboards in a sense, up through the depths from the mantle, up through these structures, are actually, it's right part, like it's right in time in with this gold event. So that's what makes this whole system so unique. So when you look at the whole island as a whole, and this is what really got me excited about the island, was, and this was the aha moment, that when you look at the mineralization from Cape Ray all the way to Baybert and everything in between, here's Marathon, it's all relatively the same gold pulse event. So in a nutshell, this is the same DNA from one end of the island, at least in the center dunnage zone, that when you find gold here and find it at the Baybert, it's from the same basically pulse. And that's what's kind of really cool now, which this sets it up for that all structure is key here. Like, you know, the whole point is like not one is better than the other. Now you just got to figure out where did the gold land. But the whole island, at least the center part, is all game, and it's one big event. So now we hear a lot about the Fosterville, Bendigo, Ballarat area in Australia. You know, how close is that analogy really to the island? It's extremely close. Like, so here what I did is I took out some data from some research papers of the Bendigo Ballarat and their time in with the gold event. And here I added Hamish's time in basically in this box. And I added the government, the Newfoundland data from basically some of their research papers. But all I'm showing you here is this is the 374 event. That's roughly 410. That's probably the 420, and this is 427. And what we're seeing here is that the gold pulse that happened in Newfoundland happened exactly the same time as in this Bendigo Ballarat area in Australia. So the settings are quite the same. And even from a geological point of view, they are with the same kind of rocks. But the big thing to take from this is the whole rock setup was done ahead of time, and then the pulse all hit basically once this prep was. So it was a pre-setup, and it was very unique kind of geologically and the timing of the gold mineralization. So and then, you know, Dave Evans, again, another geologist from the survey back in '96, was recognizing this kind of, that we were having different expressions. You know, they would find gold in one end of the island and they find gold at the other, but they had different, you know, geochemical characteristics. But that was based on if you had a pulse of fluid coming up, and it's expressing itself in different settings. Here's a saddle reef, more like the Bendigo Ballarat or the basically, and then you got these potential shear zone areas. But the point is like, this was '96. Now we have much more data to understand the big picture. So the next piece of the puzzle is, can we actually find anything on the island, especially using soil geochemistry that I use quite a bit. So because this area did get glaciated, it's a lot different from the Yukon. And the idea was that, again, the government, Martin Batterson and Dave Liberman, they basically put out some good research papers. And what we end up figuring out is the island is unique. And this is the Laurentide gold, basically glacier on the main continent. But the actual glacier that happened in Newfoundland was quite local, and it basically had short diffuse trains. So it wasn't like this Strange Lake, and this is Strange Lake, and this is kind of the double-edged sword. So if you're looking for a diamond pipe, this was a rare earth thing, rare earth basically kind of showing or deposit. And you could see the smear was out up to 40 to 50 kilometers away. So if you're looking for diamonds, let's say, that's how you would backtrack and find these things, by seeing the signal way down here, way out from it. But this would be a nightmare if you were looking for gold and you had your, you know, your gold project here, and find out that the gold on your project in Till came from 30 kilometers away. So I partially think this is why a lot of people kind of ignored the tills on the island for the last few years, because they were more concerned that it might be like a Strange Lake kind of factor here. So now when we actually look at the superficial geology, these are all pieces that we needed for exploration. And the idea is that, again, the government puts out these great maps. And this helps us with the probability when we sample these areas, you know, what's our response going to come into or come out. And the brown was showing you where there's rocks or concealed rocks. The light green is till veneer, and some of the heavier greens are basically thicker, basically sometimes till blanket. So that kind of gives us an idea of what we're expecting from a response if we're going to tackle this with soil geochemistry. Now, what drove the island, like in this 88 to 89 rush? It was this big regional lake set sampling. And the interesting part was the GSC, Geological Survey of Canada, basically gathered most of that data in the late 1970s, but they only assayed it for base metals. Someone had the really good idea in 87 to actually assay it for gold, arsenic, and antimony and release that in a public database. So this was unique, is they actually released a lot of data at once. And this is what it looks like. All the red was all these different map sheets. Now these are quite a few different map sheets here. A lot of ground. That was all in this 87, 88, 89, and the green was in 90. So the idea is that they actually produced the big picture right away, and that basically these companies like Noranda and Inco and stuff like that, and some of the other juniors all came out of the gate with one nice big map to work with. And hence, that started this mini gold rush. But like I say, it ended pretty quick by 89 with the super flow through crashing in Canada. Now, since then, they've been gathering till, and that's kind of been like, and that's almost more of a direct method because you're closer to potentially source if it works well for you. And the idea is that, but you can see how the survey's slowly been producing basically data covering the island partially, but they still got more to go. But you could see how the window of release dates is basically, this is over the, almost 15 years. So the picture is slowly evolving. It's not jumping out like it did with the lake sets in one shot. But what's interesting is the government's putting some nice data. This is Jennifer Organ. She's still working with the survey. This is her 2014 report of the Red Indian Lake Basin area. And you can kind of see the data that they're gathering. And what's so interesting about this is this data was only put out after that second gold pulse event, the 2004 or 2 to 2004 event. So this is really new data to work with that nobody's actually worked since, like some people are working with it, but we haven't really utilized this kind of piece of data. People were worried about that strange lake phenomena potentially smearing for kilometers. Here's just a quick map, like these are taken from their reports. And this is Mount Peyton. It's a gabbro, and this is the gabbro area, and this is part of the granite area. And what you could see here, this is chromium. The chromium hasn't left this basically gabbro. It's hanging right in there. So, strange lake, you'd be seeing it smearing somewhere for miles. And then you look at zirconium, and you can see how tight it is to that geology. So what we could see is that till geochemistry is working, and it's actually really working well to define the geology, which hence should define gold basically systems. So, and this was what they, so far the coverage, this is from their GeoAtlas, another great site to work with. And this is gold, and you could see basically all the blue dots lighten up. This is the Gander area, this is the Millertown area, this is the Marathon area. So basically, this is, a gold map of where to start looking for gold. But the point is, just because you don't see basically anomalies here and there, I'm saying it's not spreading, your spread from a gold like till is probably only 30 or 40, maybe 50 meters away. So it's not like 500 meters smears or stuff like that. It's quite local. Now, the next piece of information that I was able to dig up is this Rodney Clausen that was working for the GSC. Again, another good character working for the survey for over 25 years as a geochemist, working in Labrador and across Canada. And he noticed in 93 that there was something happening that as he dug deeper through the till, he got a better response. And everybody historically was working with B horizons, and he actually started questioning that. And that's what we started seeing when we were there in 2015 doing some research. But really what he vectored into is you actually had to get below. There's a weathered profile in the top, almost 80 centimeters to the meter in the till. And you have to get below that. And it's getting to this BC horizon, which is normally 50 to 100 centimeters. So it's below what we normally take as a B horizon. And again, that's what his basically gist was, is that you got to dig deep, try to get as deep as possible past that basically weathered profile. And once he started looking at it a little bit more, his take was, because when they're doing tills, they're usually 230 mesh or 180 mesh, which is very, very fine. But his take was that even 80 mesh would work, especially when you're doing exploration in tight, basically spaces. So, you know, these were kind of, as I look at it, as good wins, because this is a lot cheaper to explore if you could use 80 mesh and just dig a little bit deeper. Now, this is basically a picture, and you can see this is the B horizon here. That's where everybody would sample. And his take was, you got to get past that, get into the BC, and then, or try to get down to the C. But that's usually sometimes too deep. Now, even the BC geoscience guys were working on this, and here's the C horizon, the blue, and the light green is the lower B. And you could see that they're actually getting better responses with basically the lower B, and sometimes with the down by the C horizon. And again, they were actually like not caught off guard, but everybody's been looking at the B horizons all the time. And these guys could see that, even though the reason why we're taking Bs was because of the iron and magnesium enrichment, it was still actually better to go lower down. So this is kind of brand new data we're working with in these glacial environments. So now that was kind of the setting, and now I'll go through some case studies and talk about various basically deposit areas or showings on the island. And so this is Marathon, largest undeveloped gold resource, you know, in the Atlantic. But the idea is that you could see how they've been slowly building up this resource, you know, incremental at a time. So now when we actually go back to the history to see, you know, how was it discovered? It was discovered by soils. And they actually kind of tapped into this in the 83 to 85, Abitibi price. And, you know, they didn't do any follow-up. And then BP came in 85 to 92. And they basically gridded it on 100-meter line spacings, 25-meter station spacings, did good old mag VLF, and started outlining the, you know, the earmarks of this deposit. But you can see the structural setting. Here's your Dog Bay line area, and this is the grub line. So, you know, your Keats showing is over here, and here's your Ballantynes on the next big structure. And so that's kind of what this is all about: structure, structure, structure. So let's have a look at the Marathon system. And what you can see is this is a mag map, first vertical derivative. And the idea is that here's the geology. And that's what's kind of cool about Newfoundland. Once you tap into one of these structures, there's usually more of these deposits along these structures going for kilometers. So now, how do we vector into this? You know, how do we find this, you know, quicker and faster, you know, using our modern day science? And here, let's go back to this. Now I'm just making it transparent, but you could see this magnetic feature coming out following that structural. So we could see that. And this is mag first vertical derivative. And these blobs, these nice magnetic features, are gabbros. So sometimes the gabbros are not directly related to the deposit, but they're always very close. It's the oldest gold camp on the island, and they ended up basically doing more soils and actually finding more of these deposits. And again, the whole thing is this one's basically found in gabbros. So we got this gabbro soils kind of affinity working. Again, but this was kind of unique up to as late as 2014 with the soils and working, and they're into the gabbro area. So that's what we're getting at is, you know, soils and gabbros and geophysics on structure kind of seems to be a theme here. So here, when you started evaluating the area, you could actually see that this area is in till veneer, and it has a magnetic component to it. And here, as you can see, here a bunch of gold anomalies sitting on these first vertical derivative, basically mag features, which are the gabbros. So Steve Piercy from MUN did some work on it in the area, and you know, his take is that these gabbros, you know, they're a nice brittle rock. They crack right nicely, but they're really iron and titanium rich magnetic rock or magmatic rocks. So they're actually help the gold dump out as a chemical dump. So it's got a twofold thing going. So we can look at the hammer down. This one, Maritime Resources, is putting this into production. Again, look at this, Noranda work. They were on top of this, following up on basically sample, like on lake sets. And you can see this pattern here. This is their original geochem map. This is on 12.5 meter spacings. And the idea is that, like they could have missed it. It looks kind of like very narrow. What does it look like when you actually look at it? Here it is here. And you can see these are narrow structures coming up with mineralization. Hence why we got this kind of bizarre pattern. It's not a big blob. So, but again, what do we see? A common theme. It's basically a magnetic feature, which are gabbros. And you got these structures cutting across here. And so when you look at the till, and so to see how well it worked or not, this is actually in till blanket. So it was pretty good that they actually got any response in here, because normally they don't see too much in till blankets with B horizons. So, but the famous Keats showing that everybody's talking about from what Newfoundland Gold was on, again, this was a Noranda product back in basically in the late 80s. They were doing soil samples in the area. They actually basically got a nice soil anomaly going on. And then Fred Keats and Peter Tallman back in '94 were walking around and finding these crazy high-grade boulders. They were right on the edge of the Keats showing. It wasn't until a few years later that when Peter Dimmel came in and worked with another junior in 1999, they did these nice big soil programs, cut across it. And this is the background map that you could see. This is our soils. And here's our Keats showing. And the idea is that, soils responded. When we look at the, basically the superficial map, we can see it's in till veneer. And, there's a bunch of dots here from the till, from the government survey, but you don't see too many dots around here. And that's my take is if you're not right on top of it, sometimes you don't get a response. But again, the beauty of these systems, just like the Valentines, is that you could see how long these things go. These things go for tens of kilometers sometimes. So this is about 8 or 9 kilometers, maybe a little bit longer. So that's what's, so here's the Lotto up here and the Keats, and here's the Knob, and there's still some more of the Grouse down by the lake. So these are, once you get into a good structure, she goes for miles. So when you look at the geophysics signature, here's tilt derivative, and here's horizontal tilt derivative. And you can see this little blowout, this little boop. And here's the Keats showing here, and that's the direction they drilled. But when you stand back from the high level, here it is here, here's the Keats, and here's the Lotto. You could actually follow these things just like a sidewalk. These structures, and now it's up into lab gold ground. That's what they're chasing, the big vein. So you could see these structures. These are all structures. So the point is we can now see them with geophysics. Again, the H pond, not too far away. Again, it's in till veneer. They did some soils. You can see these nice linear soil anomalies popping up. And here you look at the MEG and geophysics, and you could actually see here it is here. And there's another system down here. So now you actually have a way to actually kind of help you hone into these. And so this is the Snow White, and this is kind of a really good example in the Millertown area. And the idea was these guys were in the 2000, this was from the Rubicon days, and they came in and you could see how they did this big grit, and they cut across wide space lines, still doing 25 meter soil spaces, and they hit a good hit. So here it is here, it's a Linda Snow White. And the idea is they came back in and filled in with a bigger grit. And so this is what we're trying to figure out. Can we hone in on these targets without kind of doing like big, massive soil grits? Can we target? Can we be more strategic? So when we look at the Snow White, now this was now hindsight with better data. This is basically a GSC map that they put out at the end of 2005. So these guys never had it when they found this. But we could see is this nice Caradocian shales along the structural corridor. And then when we look at a little bit more detail from the assessment reports, we could actually see gabbros. So gabbros, we could see. Structure, we could see. So now let's have a look at this. This is the gold map that they had from 2005. You can see they got some sporadic hits in here, and same up here. Let's look at the geophysics. We add the geophysics, and you can see the magnetic signatures behind it. Even these guys up and over here are related to these magnetic little lines in here. So when you add the geology to here and you add the geophysics, now we may have a method to hone in on this target, instead of wildcatting these big lines. You look at arsenic, multi-element geochemistry now that we get with our data packages, and look with how this arsenic is related to the mag. It works beautifully. So these guys, I think it's Great Atlantic guys that have this. These guys just have to walk down this structure, this gabbro, and start poking holes, because they actually pulled out like a 1.9 meters of, or 1.1 meters of 19 gram material. So, you know, it was a good hit, you know, so now there's more hits. That's what we got to do, hunt on these structures. But now you could start to see how we have a method to hunt for these things. So this was some more research we did in the Millertown area, just south of that. Basically, here's the Linda Snow White over here. So we're just down, lower down in the valley. And the same guys who found that 2005 soil anomaly, the Linda Snow White, they were working this big valley down here. They were working lower down. And so again, but they were using B horizons. And this is where I'm all about now. It looks like we have to go deeper. But these red areas, so you can see where they got nothing. Here's their soil lines going across here. And these red circled areas, I'll show you what we picked up. But you could see their response was nothing with Bs. This is till blanket, so it's a little bit deeper. And now when we look at ours, boom, now we could actually see some nice anomalies. They're not wild numbers. What they are is, you know, these are 90 percentile anomalies, so based on a good population. But you could see how linear these basically anomalies are. And that's what I'm getting at, is we're now seeing responses, mostly, well, for a couple of reasons. One, we're digging deeper below that oxide level. And two, I think we have better detection packages with our ICP-MS these days. So again, so now you can start we're using modern day science to help us out quite a bit with this gold exploration. So and here's another basically setup here. This is in the Gander area on lab gold ground. And the idea was, this was Gander Minerals, 1989. And you could see the background lines here that they sampled, and they got nothing. And the same with down here. And now look on the other side. This was my 2019 work. And you could see the response we picked up. Again, why? I believe is because we went down deeper and we got a better response. And so that's what I'm getting at now, is I think deeper soils is going to be the method for this exploration based on structure. Like, you know, we're running down structure. So, and then Lab Gold, it's what they followed, that cookie cutter formula, you know, and they basically ran in, put some big soil grids in, and that led to basically seeing their patterns, and, you know, which led directly to finding their big vein. And the idea is that you could see these soil anomalies. They didn't have the rest of the soil database before they made this figure, but you could see, you know, they're finding quartz veins with VG in it, or mineralized quartz veins, you know, paralleling these soils. And that's what we expect. So that's kind of what I'm getting at, is, you know, the idea is to get in and take deeper soils, but you have to understand your superficial, you know, geology to understand the context of what the soil anomaly is going to look like or need. So that's my talk. You know, I believe it's the dawn of a new gold rush, and I think this is just beginning where Naranda left off. Thank you.